Hello, George Romanic here. Today we are going to talk about Gay-Lussac's law or Amonton's law. This is another experimental law that precedes the current state of the kinetic theory of gases. This law was discovered by people doing experiments. Amonton doing experiments with air, Gay-Lussac with other gases, and so on. The law is very simple and it says, if we keep the volume of the gas constant, then pressure and temperature are directly proportional. That means we increase temperature, we are increasing pressure. We increase pressure, we are increasing temperature. This law, similar to Boyle's law, has many applications in our everyday lives and can be used to explain many phenomena that we see around us that involve air. So let us discuss this law in terms of the equation of state of an ideal gas and discuss some of these interesting phenomena. Gay-Lussac's law says that pressure is equal some constant times temperature if the volume is held constant. Or quite often people would write this as pressure over temperature is a constant. This law can easily be derived from equation of state of an ideal gas, where we have that pressure times volume is the number of moles in that volume, universal gas constant times absolute temperature. Well, if volume is held constant, and that's the whole premise of Gay-Lussac's law, N is number of moles in that volume, that's constant if we don't add or remove gas, and R star is constant. So from here, therefore, we can say that P over T is constant. That's how we get this law from equation of state of an ideal gas. Now, what that conceptually means is if we have two containers, container 1 has N moles of gas, and then the same container, same volume, but condition number 2 is that we add heat to this container over here. So what will happen in these cases? These two have the same volume, but this one we are increasing temperature, which means pressure in this one will be higher than pressure in this one. So consequently, from Gay-Lussac's law, pressure in container 2 is larger than pressure in container 1. Or we can also say that pressure in container 1 divided by temperature in container 1 is pressure in container 2, temperature in container 2. This is the most useful application of Gay-Lussac's law, where we relate two containers at different temperatures or pressures but same volumes. Of course, looking at this, you can see that the classical example of the application of Gay-Lussac's law is in your kitchen oven. Number 1 represents kitchen oven at room's temperature. Number 2 means you're baking something in your oven. And as temperature is increasing in the oven, pressure is also increasing because volume of the oven is always the same. And you know that because when you go to check on your banana bread or pizza and you open the oven, air hits you in your face, and that's because you have a pressure buildup in the oven thanks to Gay-Lussac. So slapping in face is thanks to Gay-Lussac in this case. Another application of Gay-Lussac's law is related to your tires on your car. Here is a tire in, let's say, summer, and here is the same tire but in winter. Now, this tire, both of them of course, are filled with air that is under pressure. Air in tires is jiggling. Now, in winter, temperature decreases. But if the volume of the tire is the same, that means that pressure in the tire will decrease. And you know that very well, because every time winter comes, you look at your tires and you say, oh my god, they look deflated. Yeah, because temperature decreased, consequently pressure decreases thanks to Gay-Lussac. Tires were under pressure on my car 2.5 bars during the summer and autumn. And then cold days came and my sensor was beeping saying that pressure in my tires is now 1.9 bars and I need to pump it up. So that's what I did. I went to gas station and I did it because of Gay-Lussac. If you have very good sensor on your car, you can also notice if you are driving for a long time, pressure in your tire will increase. Why is that? Well, that's because there is something called asphalt surface, and your tire is constantly in contact with the surface, and you are driving in this direction. But there is friction between tire and the surface, and friction means increase in internal energy, and that consequently means increase in temperature. Temperature of the air in your tire increases because of the frictional effect, but that also means that pressure will increase in your tire. So if you have very good pressure sensor for your tires on your car, if you are driving for a long time, check the pressure and you will see it's a little bit higher than it was when you started that trip. Again, thanks to Gay-Lussac. This video was on Gay-Lussac's law or Amonton's law. Until next video, goodbye.